Hello friends, in the last video we have seen what is the distribution function and density function of a random process. In this video we will see another important topic, that is stationarity of a random process. So here, based on how the distribution and density function are varying with respect to time, we can define several order stationary process, that is first order stationary process, second order stationary process, like that nth order stationary process. So first we will see what is stationarity, and then we will see what is first order stationary process, and then we will see the second order stationary process, and then wide sense stationary, and finally strict sense stationary process. So what is stationarity means, how we define the stationarity of a random process means, for any random process we will have statistical properties. If those statistical properties are not changing with respect to time, then such a random process we will call it as stationary random process. If the statistical properties, that is mean, variance, and autocorrelation function or any higher order statistics, if the statistical properties of the random process doesn't change with time, then they are called stationary random process. Why they are very important means, if the process is not changing with respect to time, then it is very easy to analyze and predict its properties with respect to time. So that is why they are very important in signal processing, communication, as well as machine learning. Now we will see what is first order stationary process. So a random process x of t is first order stationary. If its first order distribution function are the first order statistics, means simply the mean, are not changing, or they doesn't depend on time, then that such process is called first order stationary process. So as it is said, the first order distribution function is fx of x comma t is equal to probability of x of t less than or equal to x. The values taken by this random process, if it is not a function of time or if it doesn't depend on time, then it is a stationary random process, first order stationary random process. So because of this, the mean of the random process mu x of t, in general it is a function of time, because the distribution function and density function doesn't depend on time. The mean of the random process, statistical mean, it doesn't depend on time t. So it is simply a constant. If these two are satisfied, then it is called first order stationary process. Similarly, next we will see what is second order stationary process. Second order stationary process means it has to satisfy the first order stationarity as well as the second order statistics, like autocorrelation function. Specifically the autocorrelation function, actually it is a function of t1 comma t2. We'll write autocorrelation function rxx of t1 comma t2. If it is a second order stationary random process, then it is should depend only on tau. What is tau? Difference between t2 minus t1. It should not depend on t1 and t2. It should depend only on the tau, which is t2 minus t1. So a random process we will call second order random process. So if it has constant mean as well as constant variance and it should also, the autocorrelation function should depend only on the time difference tau. It should not depend on t1 comma t2. It should be rxx of tau. Tau is nothing but the time difference t2 minus t1. So if these three conditions are satisfied, then it is called second order stationary random process. Next, we will see the another important one, wide sense stationary process. Wide sense stationary process. It is the another term for second order stationary. But what is the difference between second order stationary and wide sense stationary process means it should not require all the distribution functions. It doesn't require all the probability distribution functions. So we have only, we it has to satisfy the only two conditions. It has to satisfy only two conditions. One is the mean should be mu x of t. It should be expectation of x of t. It should be constant. It should be constant. It is not a function of time. And the second condition is autocorrelation function depends only on time difference tau. That means rxx of t1 comma t2 is, we can write, or we should be able to write rxx of tau. What is tau? It is t2 minus t1. If it is satisfying these two conditions, then we can call such a random process as wide sense stationary process. So it doesn't, wide sense stationary process doesn't require the variance constant. So for second order stationary process, it requires constant variance also. For wide sense stationary process, it should have the mean constant, and autocorrelation function depends only on time difference tau. Then we call such a random process as wide sense stationary random process, or in short, it is called as WSS process. WSS process. So we'll see in the form of a table. First order means the mean is constant, variance constant is not required, and autocorrelation is also not required. It is not a function of time tau, and it is also higher order statistics also not required. First order stationary, mean only should be constant. Mean should be constant. For wide sense stationary or second order stationary, in general we can call the mean should be constant. For second order stationary, the variance also constant, and the autocorrelation function also depends only on the time difference tau, and higher order statistics are not required here. And the next generalized definition is strict sense stationary means the mean should be constant, variance is also constant, and autocorrelation function also depends on time tau, and all higher order statistics are also should be constant. If all higher order statistics are constant, then we call such a stationary random process as strict sense stationary random process. So these are the things that are need to be satisfied for first order stationary random process. For second order stationary, or in general, if it is a second order stationary random process, then it is also a wide sense, then it is also a wide sense stationary random process. And for strict sense stationary random process, the mean should be constant, variance should be constant, then autocorrelation function should not depend on t1 comma t2, and all higher order statistics are also should be constant. So these are the things that we have seen in this video. What is stationarity, and what is first order stationary random process, and then second order stationary random process, and then wide sense stationary random process, and finally strict sense stationary random process. I hope everyone is able to understand the difference between first order, second order, and strict sense stationary random process. Thank you for watching. Please like my video and subscribe to my channel. Share with your friends. Thank you.